Hi, welcome back. This is Mr. Erlin. So far we've been dealing with using trigonometry to find missing parts of triangles that were specifically, explicitly right triangles. And it's true that that's where trigonometry works. But we can leverage that in some different ways using something called the law of sines. Now the law of sines says that the sine of an angle, A, is in a ratio to the side opposite it, such that it's the same ratio as if I were to take the sine of B and the length of the side opposite that, and the same ratio as the sine of the third angle, C, in a ratio to the side opposite that. So that means that when I'm looking at a picture like this, I can maybe make some conclusions based on this. I can find some missing sides and angles. It's called solving the triangle when you find all the missing parts. So my recommendation is that you always start by building a little box of your values to keep track of it. And we're given certain values. We're given the value of angle A, that's 50 degrees. And we're given angle B is 80 degrees. We don't know angle C yet. We don't know, oh, wait a minute. Opposite A is little a, so I do know A is 10. Opposite B is little b, I don't know that. Opposite C is little c, I don't know that. This is what I'm given. And there are actually two laws. There's law of sines and law of cosines. Law of sines is by far the easier one to use, and it can be used if you have a ratio that works. See how I've got angle A and side A. That gives me a ratio that works. And I've got the angle B, so I can solve for B. So the first step would be to choose the ratio that works. So sine of A is to A as, and I've got part of B, so I'm going to use sine of B is to B. I'm going to ignore C for a minute. And then I'll substitute and solve. So sine of 50 over 10 equals sine of 80 over B. You don't know what B is yet, we'll solve for it. This is now our proportion. As we learned in our similar triangles unit, I can use cross multiplication to solve a proportion. What's being done to B? I'm trying to solve for B. It's not isolated yet. Right now it's being multiplied by sine of 50. So if I want to solve for this, I have to divide by the sine of 50 to undo the current multiplication. Those cancel, and I'm left with a precise value of B is equal to 10 times the sine of 80 over the sine of 50. That's not very helpful to me, though. It doesn't tell me whether it's 12 or 10 or 8 or 7. So I'm going to use my calculator to enter that in. 10 times sine of 80. Make sure I close parentheses on that sine of 80 so that I'm not taking sine of 50 within that, divided by sine of 50. And I get approximately 12.85575219. I like to record that whole value down here, even though my final answer is only asked to be to the nearest hundredth, at which point I'd say this is my solution, so round to the nearest hundredth would be 12.86. That's what I'd put up here. But if I decide to use that value later in the problem, I'd want to use more decimals. I usually like to use 4 decimals beyond my rounding spot because that will keep the level of precision I need for most operations. All right, so now I want to get into C. That means I need my sine of C over C, but I have neither the angle nor the side. Well, in fact, we can find the angle pretty easily. What do we know about all 3 angles in a triangle? We know that A plus B plus C has to equal 180. Therefore, we know that 50 plus 80 plus C equals 180. 130 plus C equals 180. So C is another 50. Interesting. So what can we predict is going to happen here? If in fact C is 50 and A is 50, what kind of triangle is this? Should be an isosceles triangle, shouldn't it? Therefore, we're going to expect that while we've just discovered that this is 12.86, we can predict that C should be 10 units because it's an isosceles triangle. But let's go through the process and see if it works as well. So now I know that I want to get C involved. So I'm going to use sine of C over C equals, I can choose either of these ratios, sine of A over A or sine of B over B. If I choose the sine of B over B, I'm going to be using a value that is in some way rounded. So that doesn't seem as precise, so I'm going to choose this one. So A, sine of A over A. Now I guess this is going to become trivial that way, because then I'm going to get sine of 50 over C is equal to sine of 50 over 10. And we can see that these are exactly the same ratios, so C is going to be 10. So I didn't really plan to do this, but let's do it the other way. Let's say that the sine of C is to C as the sine of B is to B. And so we'll say that the sine of 50 is to the unknown C, as the sine of 80 is to 12.855752. I'm going to bring it over here. And I'm going to cross multiply. So I'm going to get C times the sine of 80 is equal to 12.855752 times the sine of 50. I want to solve for C. Right now it's being multiplied by the sine of 80, so I'm going to divide by the sine of 80. So C is equal to 12.855752 times the sine of 50 over the sine of 80. That's my relatively precise. It's actually not precise because this one's still rounded. In fact, I've still got that value in my calculator. So what I'm going to do is I'm just going to press times sine of 50, close that out, divide by sine of 80, make sure I do that correctly. And what I end up with is C is equal to 10. Comes right back where we expected. Oops. But it doesn't always work out that it's isosceles, but the same process will hold true. That's how we use the law of sines to find missing sides and angles. In other words, solving the triangle.